Now, we're almost at calculus, but let's clarify the last bit of semantics, which is this symbol right here together with this one, and let's say some formula. Right, what does this mean? This means that this, which is a formula, is of semantic consequence to a set of formulas. So this is a set or a group of formulas. So what does this mean? What does a set of formulas mean? A set of formulas, so a set of formulas, let me put it right here, equals any group of formulas, like let's say that one, and psi, then this one. Oh golly, okay. So this one has its own truth table, so it has the truth table 1, truth table 2, sorry, truth table 2, and this one has truth table 3. For each of them, let's say that the formula, so the semantics of each of these formulas, like this formula here and that formula, they have different semantics. Okay, so the semantic valoration is not equal for each of them. However, they belong in the same set of formulas because their tables are exactly the same. So the valoration for each and every formula within this set of formulas has exactly the same output for any given input. So I O for any for any set of formulas, right, will be the same. Okay. Sorry, that one was a mistake. Yeah. So any input that produces an output must imply that if it is within that group of formulas, it must have the same valoration. So the final result upon giving input to any of its variables. So let's say that, for example, if phi is a formula where we have the x variable in conjunction with y, and then we define a table like we did before where x and y can be given 0, 0, 0, 1, 1, 0, 1, 1. Then we get x conjunction y, and this we will have to apply the previous knowledge that we know from before, which is that any conjunction will only be true when we have both to be true. So this formula, right? So this means that this formula will only be true for this scenario, and it only takes two variables, right? These have to always be the same dimension, so two variables for each. Okay, and because we get this result for this formula, let's say that, forgive me, let's say that now this other formula, which is also a double variable formula, is written in a different manner. So as you know, a different way of writing this is by negating the whole thing. So x intersection y. And let's say that the last one, so the last formula, and this too, again, it just represents the number of variables that we have in each formula. So let's say that we distribute this this negation throughout the pardon me, actually, I forgot one thing, is that to make this even, we have to negate the interior. Doubly negate everything, actually, so I kind of did mess this one up. Let me just rewrite it. Okay, so let's say this one right here. Oh yeah, actually I did a goof here. So remember, let me just quickly write a table here. You could do this by braining it out, but I'm gonna do it here because you might want to do this on your exams as well. Test truth tables out, so you know that you'll have these combinations, right? We'll start writing combinations to make sure that we're not making stupid mistakes like the one I made just now. And it goes like this. So the formula I wrote here was incorrect, and I figured it out by running input in my head, which is to say I made a small table in my head. And you can also go by simple logical arithmetic, but well, it depends on what your brain decides to do at the exact moment. So let's say now I remember, right? Now I remember that the exact opposite, the equivalent, the exact, yeah, sorry, the opposite. I may backtrack. The equivalent of writing this in another notation is by simply negating x and y and making it the disjunction. And we can prove this using a logical using a truth table and a tree. So let's begin with the internal part. Let's say, well, let's begin from the top. So we have a negation, correct? And then we have a disjunction from x and y. Actually, sorry. And we have a negation between a disjunction between negations, referring to x and then y. Okay, so let's then put this expression here. Let's evaluate it. By the way, this is the first time I'm doing this as well. So fun. Okay, so we want to evaluate this. Okay, so let's say we have 0, 0. So this is 0 and this is 0. It will be negated, it will become 1 and 1. Then the disjunction of these will be 1. One or the other is positive, so it is 1. And the negation of all of them is 0. So the result for 0 and 0 will be 0. Now we have the next one, which is 0 and 1. So 0, 1. The negation of 0 is 1, the negation of 1 is 0, then we have the disjunction, the result is 1, and then over here the negation will be 0, so we get a 0 here. Next, we erase all that, follow the same procedure. So we have a 1, 0, and we negate it, and it becomes 0, 1, then union 1, and then negation 0, so 0. And finally, we have a 1 here, which becomes 0, the disjunction will be 0 and the result of the negation will be 1. So we have 0, 0, 0, 1. And that is the exact same as we obtained before in this truth table. So we know that these are equivalent in valoration, so in V. Let me quickly delete these notes down here for the time being, since we've already concluded that they are equivalent. So we know that both. So yeah, so we can say the following. We can say that given that let's say that the symbol group of formulas is of semantic consequence to both, well, now we know phi and psi, right? Now we know. And now we could prove for epsilon, I think that is the name. But okay, so it would just simply be a different way of structuring this. So the principle we're going after here is if you write them in different ways, then you have to say that like phi and the valoration of phi is equal to the valoration of psi, right? But the same is not true for the semantic valoration between them. They are not equal in semantic terms. So in valoration terms they're equal, in semantic terms they're not. So yeah. Semantic consequence. Groups of formulas and valorating formulas. That's how you do it. Oh, and the part about the confirmation with the tree and the truth tables is very, very useful to do in real time, and you'll do it in exams and tests if you have the chance. Is the best way to confirm it's a simple fail-proof way of confirming your answer, and you should do it.